Hey everyone, Houston Math Prep here. We are doing our part 1 video in a 2-part series of solving logarithmic equations. In this video, we're going to do basic equations, where we just have a single log term in our equations. If you want to do some more complicated stuff, you can check out our part 2 video, where we have multiple logs in one equation. When we're solving log equations, if you remember, for logarithms, we have domain restrictions. The only thing we're allowed to take logs of are positive numbers. So when we solve these equations and we get an answer for x, we want to make sure that when we plug that answer back into our original statement, that we're actually taking logs of positive numbers for anything that we plug into. So let's just make sure we remember to do that at the end of each log equation. Here, our first example, we have log base 5 of x equals 2. So remember, this x is really inside of this operation called log base 5. So what's happening to x is log base 5. And the way we solve equations, remember, is to just undo operations by taking the opposite operation in the correct order. So to undo log base 5, we take the inverse or the opposite operation of a log base 5, and that is an exponential base 5. So what I do is I take 5 exponential of both sides, or 5 to the power of both sides. You can see I'm using this little caret key that looks like maybe an exponent key you might see on a keyboard or for a calculator or something. So this is saying I'm taking 5 to the power of this whole side of the equation and 5 to this number 2 here. Base 5 exponential and log base 5 are opposite operations. They reduce one another. So the only thing left on the left side is x, and I get 5 to the power 2, in other words, 5 squared. If I just figure out what 5 squared is very easily, then we can see my answer is x equals 25. Now I need to check this and make sure that wouldn't have me taking the log of anything negative. If I plug this back into the original, then I will be taking log base 5 of positive 25 equals 2, and my inside of my logarithm is positive here, and so we are good. This is a good answer. We'll say x equals 25. Let's look at another one. Here we have log base 6 of x plus 5, a different term there, not inside of the logarithm, equal to 8. So if I want to get my log 6 of x term by itself, I need to subtract 5 first, and then I can work on solving for x in that term. So now I have log base 6 of x equal 8 minus 5 will give us 3. I need to undo my log base 6. The opposite operation of log base 6 is a base 6 exponential. So I take 6 to the power of both sides. Base 6 exponential and log base 6 undo one another, and I get just x on the left side. On the right side, I get 6 to the power 3. Be careful not to write these in the incorrect order and accidentally say 3 to the power 6. You'll get a different number most of the time. So here we have x equals 6 cubed. And that is, if you know it or type it in the calculator, 216. We go back to the original with 216 and check. If I plug in 216, am I only taking logs of positive numbers? And you can see that we do. If I plug in 216, I will have log base 6 of 216 plus 5 equals 8. And inside of this log here is positive, so we know we're good. And we'll say that this is a correct answer for the equation. Looking at the third one here, log base 3 of x plus 1, now the add is inside of the logarithm, equal to 4. So I need to get at that x plus 1. Let's work from the outside in on my term here. I need to undo the log base 3 first. The way I undo log base 3 is with a base 3 exponential. So I do base 3 exponential as an operation to both sides. 3 to the power of something and log base 3 of something are opposite operations. They get rid of one another, and we get x plus 1 is equal to 3 to the 4th power. Let's go ahead and figure out what 3 to the 4th power is. So you can do that quickly in your head, or you can type it in the calculator, and 3 to the 4th ends up being 81. And now I have x plus 1. I just need to get rid of my plus 1. So I'll subtract 1 and get an answer, x equals 80. I go back and check in the original. If I plug in 80, log base 3 of 80 plus 1 equal to 4. The inside of my log would be 81, and I know that's a positive number, so I know that this is a good answer. No domain problems for my logarithm. Looking at the next one here, 2 times log base 2 of x plus 1 equals 13. There's a lot going on in this first term, but let's get rid of the plus 1 first at least and just work with that single term. So subtracting 1, we'll get 2 times log base 2 of x is equal to 13 minus 1 gives us 12. Working from the outside in on this term, I have times 2 on the outside. Let's get rid of multiply by 2. Opposite is divide by 2. So we'll then have log base 2 of x is equal to 12 divided by 2 ends up becoming 6. I need to get rid of, finally, my log base 2 operation. Opposite of log base 2 is base 2 exponential. So I take 2 to the power of both sides. 2 exponential and log 2 reduce, and we get x equals 2 to the 6th. If you type that in the calculator or happen to know it off the top of your head, you get that x is equal to 64. Let's go back and plug into the original and make sure we're good for domain. So we have 2 log base 2 of, if I plug in x, I get a positive 64 in the log, and that means that everything is good to go. This is a positive inside the log, so we are okay to say that x equals 64 is a solution. Looking here at 3 times log, this is base 10 since no base is written. 3 log of x plus 10 plus 2 on the outside of the log equals 11. So let's get this term by itself first. We'll get rid of the add 2. We'll subtract 2 on both sides. That will then give us 3 times log of the quantity x plus 10 is equal to 9 on the other side. I have times 3 on the outside. Let's get rid of that outsidemost idea. So we'll divide by 3, and we'll get that log of x plus 10 is equal to 9 divided by 3 would give us 3. Now this is log base 10, remember, when the base is not written, so the opposite of log base 10 would be a base 10 exponential. So we take 10 to the power of both sides. Base 10 exponential and log base 10 reduce one another. So we'll get x plus 10 left on the left side, and 10 cubed over here, 10 cubed is going to be 1,000. If we complete this by subtracting 10 minus 10 on both sides, we'll get that x is equal to 990. If we plug that back into the original problem, we will get 3 times the log of 990 plus 10, which is definitely a positive number, plus 2 equals 11, and so we know we're good there. 990 for an answer on this one. For our last one here, we're going to go ahead and convert our answer to a decimal and round to 3 places just for some practice. So we have the natural log of 2x plus 1, all in the log, equal to 3. So everything over here is inside of the natural log. Remember that this is a log base e. So I have a log base e, and I want to undo the operation log base e. How I undo that is an exponential base e. So we take e to the power of both sides to undo log base e on the left side. Exponential base e and log base e are opposite operations. They will undo one another. So we'll get 2x plus 1 left on the left side. And here we'll get e cubed, whatever that number is. Let's do that at the very end. We'll just do all the stuff in the calculator at once. So what do I need to do next? I need to subtract 1. So we'll get 2 times x equals e cubed minus 1. And then to solve for x, we'll need to lastly divide by 2 on both sides. We'll get that x equals e cubed minus 1, and all of that over 2. If we type that in the calculator, then we should get that x is about equal to 9.543. Before we decide that it's an actual answer, let's make sure if we plugged that back in, would we get a positive number inside of our logarithm? If I plugged about 9.5 in here and multiplied it by 2, it would still be positive. And then if I added 1, it would still be positive. So I think we're good. We check on this one. We would be taking log of a positive number here. We'll go ahead and say that our x equals about 9.543 is good. Okay, those are basic equations where you just have a single log. If you're looking to move beyond this, go ahead and check out our part 2 in the series, where we work with multiple log statements in a single equation. Thanks for watching, everybody. We'll see you in the next one.